Okay guys, welcome. Today we're going to talk about the discriminant, and I thought I'd give you a little bit of a video to help you understand it. It's something that you've already been dealing with. So you've been dealing with this equation here, the quadratic formula, and you've been using it in the last lesson to find the equations of the solutions of quadratic equations. So if you've got ax squared plus bx plus c equals 0, then we can find these solutions by using this formula and putting it into negative b plus or minus square root of b squared minus 4ac all over 2a. Lovely equation, isn't it? But this equation has two parts to it that we're going to analyse further in this course. The first one is something that we're going to come back to later, and that's this negative b part, or rather the negative b over 2a part. So that's something that I just want you to lock away, and later when we come back to graphing, it's going to be something that's important. But the other thing that we're going to analyse is this part inside the square root. So the b squared minus 4ac part. And this has this fancy name. It's called the discriminant. And it has this symbol here, which is just a triangle. And so the discriminant is equal to b squared minus 4ac. And you might be thinking, well, why do we need a fancy name for just part of a formula? Well, the important thing to notice is that the discriminant is inside a square root. So have a think for a moment. What sort of numbers can you square root? And so obviously we can square root square numbers. They give whole number answers, but we can square root anything that's number greater than or equal to 0. So any number that's greater than or equal to 0 can be square rooted, but if it's less than 0, like a negative number, what can we do? In fact, there are solutions to the square root of negative numbers, but they involve complex numbers or imaginary numbers, and we don't go into that unless you do some very higher levels of maths later on. So let's look at what this means when we're analysing an equation. So here are two examples. First example, we've got 2x squared plus 5x plus 3. And if we just look at the discriminant part, not the full quadratic formula, just the discriminant, that's the b squared minus 4ac part. And later we'll be able to do this in our heads. So b squared minus 4ac in this case is 25 minus 4 times 2 times 3, which is 1. And so in this case, we get a positive answer for the discriminant. So in our formula, we'd have plus or minus square root of 1. So when you add or minus something, you're going to get two different answers, aren't you? Can you guys see that? So plus or minus square root of 1, plus or minus 1, we're going to have two answers of some sort. But in example 2, the discriminant, when we figure it out, gives something negative. I don't really care what it is, it's just a negative number. And because it gives something negative, we've got the square root of a negative number, we can't do that. We don't get any real answers to that problem. And so we can say there are no real solutions to this equation in example 2. It doesn't have any real solutions. So the discriminant, by looking at that alone, lets us know how many solutions an equation will have. So we didn't look at one of the examples, one of the possible things that might happen. So let's talk about them here. In our quadratic formula, and I've simplified it a little bit here, if the discriminant is less than 0, then we get no real solutions because we can't square root a negative number. If the discriminant is 0, and this is the situation we haven't talked about, then we get plus or minus the square root of 0, or plus or minus 0. If you add 0 or minusing 0, it's the same thing. So in fact, we just get that answer x equals negative b on 2a. And lastly, if the discriminant's greater than 0, then we get two real solutions. And that's what we're most familiar with so far, but we'll see lots of examples that don't give two real solutions from now Okay, so I hope that this helps, and yeah, let me know if you have any questions. Okay.